So, welcome guys to the next cyber workshop in the Cybersecurity Reloaded workshop series of Q Project. Today we're going to be talking about authentication of routers. So, I want to introduce router and device authentication and other basic services which are executed, which are known as DHCP and ARP. DHCP stands for Dynamic Host Configuration Protocol. This is basically where you get your IP addresses. ARP stands for Address Resolution Protocol. Basically, it maps these IP addresses to a MAC address. Basically, each of these services, including the authentication between the router and device, happens in 4 steps. Of course, these may change depending on the protocol, but these are basically the overall steps used for authentication and these services. So the client would send something of a broadcast query to every node on the network in the broadcast channel. Then the router would reply with its own MAC address and the new IP address it assigns to the client. The client then caches the response, then sends a authentication request or association request for DHCP/ARP, and then the router caches the device's MAC as well as IP addresses, and it replies with the corresponding response known as ACK. ACK stands for acknowledgement, or short for acknowledgement. There are different types of wireless security protocols. First one is WEP. This stands for Wired Equivalent Privacy. So when your computer is connected on Ethernet and there's nothing in between the Ethernet cables, it's said to be very secure, your Wi-Fi, because you're getting it straight from an actual wire, hard connected wire. And that's why people say it's more secure than wireless, because you can inject packets and do all that crazy stuff. And this first type of protocol was designed to provide the same security offered in wired connections. It ran from 1999 to 2004, and there are many problems with this, and that's why it just stopped running at 2004. WPA stands for Wi-Fi Protected Access. This is the second type of wireless security protocol. It was adopted formally in 2003, and its firmware was available on WEP devices and ran WPS, which is known as Wi-Fi Protected Service. No, Wi-Fi Protection Service, or something like that. And this WPS is pretty weak and allows for attackers to brute force WPS. WPA2 is the third different type of wireless security protocol. It was adopted around 2004. This is great for home networks, and it uses AES encryption. This is what is used right now on your home network, most probably. And then there's WPA3, which is coming soon. And this is a very special type of Wi-Fi. It actually avoids man-in-the-middle, traffic sniffing, all those extra, extra attacks that the WPA2 is vulnerable to. So I'm going to describe a quick attack on WEP. It's called the Caffe Latte attack. So there's basically 3 big steps. The first step is you launch the attack. So first you would wait for ARP packets from the device to the router, from the legit device to the router, and then send a specific ARP request to the router, formulating the source as the legit device. Then since your own malicious device is created as an AP. It sends a broadcast message using a gratuitous ARP standard to mimic the legit AP. And this is done by changing the malicious device's access point SSID to the legit AP SSID. Then the next step is to capture the packets. You have to capture the packets from the device to the legit AP. Then, as the ARP requests are sent to the device, you receive those packets, and then you save those packets. And so those packets have the WEP key, which you use aircrack ng, which is a program on Kali Linux, to crack the WEP key from the various ARP packets or various packets you captured. Use systems, you use decryption systems like FMS and PTW to crack it. The best case scenario takes 6 minutes to crack it, and a worst case scenario it takes only 2 hours to crack it. So it's pretty easy to crack WEP Wi-Fi. Okay. Now, we want to know how to crack WPA2, which is what we use. WPA2 is the most common Wi-Fi protocol because it's the fastest as well as the most secure, like as of now, and it's the most widely adopted in home networks and a decent number of enterprise networks, small enterprise networks. It uses AES, Advanced Encryption Standard. It's good for home networks, but also not enterprise because you can see other devices on the network. It uses the unsecure WPS Wi-Fi protected setup, which is I was talking to you guys about earlier as well. And Wi-Fi protected setup is a system that takes about 2 to 14 hours to crack, and this is often a password that's scrutinized under an offline dictionary attack if you have the password list, such as a dictionary, and then you have the actual encrypted password. So another way to crack WPA2, instead of capturing the packets, the password, and then trying to crack the password, is to capture the actual handshake. So what a handshake is that when devices are connected to a router, and when you're sending data, you send it with some extra code, which is known as a handshake. So basically, the router knows that this Wi-Fi packet came from that device because of that special handshake. So if you capture this handshake, you're able to mimic a Wi-Fi connection from that device to the router. When routers and devices are connected, they use a four-way handshake system. It's decently poor security for today's world, and it's even more poor, even more weak, depending if you put a weak password. So in today's world, it's poor security in today's world because we have all this new technology like cloud computing, and we have all these computers that can run multiple processes at in milliseconds, and that's why we're able to crack these passwords and handshakes much easy than before. And so I'm going to show you a demo. It's not a live demo, but I took some pictures of what I demoed before. So basically, I had this RPI pineapple in the previous workshop that I hosted, and I set it up. And so then I connected to the Wi-Fi, to the network, and then I basically captured the first 4 messages, which are the router to device authentication, and I'm going to show you that. So right here, I use T-Shark on the interface WLAN 0, and these first four messages are of router and device authentication. And then you see the DHCP and ARP messages being sent. So I'm using my Raspberry Pi to connect to my Apple device, my iPhone, so you can see the different messages that are being sent back and forth. This is a four-way handshake right here. So we're going to see what is in each of these messages and use it by printing these out in JSON format. So I'm only showing you the first two because it's basically encrypted. I just want to show you how the packets look. So this is the first packet right here. You have, of course, the different layers. The frames right here for the Wi-Fi frame packet. You have Ethernet right here. So the destination is the Apple device from the iPhone. So basically, the iPhone sends a signal to the router, which is a Raspberry Pi, and says, "Okay, send me the handshake request." And so the Ethernet destination would be the Apple. The source would be the Raspberry Pi, and then it has this EAPOL. So this is basically the handshake of WLAN. And then this is the second packet right here. It sends a destination and a source, of course, source from the Apple, and then destination from the Raspberry Pi. And that also has EA pool, and then these encrypted messages, which is for the handshake. And it also has this entire data tree of WLAN, which is basically more information given to, which is part of the handshake protocol. And that's it. I have my works cited right here. So thank you for attending today's workshop. I know it was short, but I hope you guys learned something. And if you guys have any questions, then please let me know in the comments or in the chat box. And thank you for attending. Thank you. Have a nice day.